commercial dishwasher rated for 120/208 volts will function on a 120/240 volts system. The dishwasher typically utilizes 120 volts for its control circuits and 208 volts for its heating element. When connected to a 120/240 volts system, the control circuits will still receive the required 120 volts. However, the heating element will now be supplied with 240 volts. This difference in voltage to the heating element is generally acceptable, as the 240 volts falls within the tolerance range that the heating element is designed to handle. It is crucial to ensure that the dishwasher is properly wired for the 120/240 volt system. This involves using appropriately sized conductors, in accordance with the National Electrical Code or NEC, to handle the increased current resulting from the higher voltage. The circuit breaker protecting the branch circuit must also be correctly sized to prevent overcurrent situations. Failure to adhere to these wiring requirements could create a significant safety hazard, potentially leading to overheating, electrical shock, or even a fire. When dealing with electrical installations, always consult with a qualified electrician to ensure compliance with all applicable codes and regulations. They can assess the specific requirements of the dishwasher and the electrical system to guarantee a safe and reliable installation. Furthermore, it's important to consider the specific design and specifications of the commercial dishwasher. Some manufacturers may provide specific instructions or recommendations regarding voltage compatibility and wiring configurations. Always refer to the manufacturer's documentation for detailed guidance. If the dishwasher is not properly wired for the 120/240 volt system, it could lead to premature failure of the heating element or other components. The increased voltage can cause the heating element to overheat, reducing its lifespan and potentially damaging other parts of the dishwasher. Therefore, it is imperative to prioritize correct wiring practices to avoid costly repairs and ensure the long-term reliability of the appliance. Consider the nameplate data on the dishwasher, which shows the voltage requirements. This data should be consulted before connecting the dishwasher to any electrical system. If there is any uncertainty about the voltage compatibility or wiring requirements, it is best to consult with a qualified electrician or the dishwasher manufacturer. They can provide expert guidance and ensure that the installation is safe and compliant with all applicable regulations. Remember that working with electricity can be dangerous, so it's always best to err on the side of caution and seek professional assistance when needed. A dedicated branch circuit should be installed for the dishwasher to prevent overloading of existing circuits. This will ensure that the dishwasher receives a stable and reliable power supply, minimizing the risk of malfunctions or damage. The dedicated circuit should be sized appropriately to handle the dishwasher's electrical load, taking into account the voltage, amperage, and any other relevant factors. Consult the dishwasher's specifications and the NEC to determine the correct circuit size. When selecting conductors for the branch circuit, choose a wire gauge that is appropriate for the current carrying capacity. The NEC provides tables that specify the allowable ampacity of different wire sizes based on factors such as the insulation type, ambient temperature, and installation method. Be sure to select conductors that are rated for the environmental conditions in which they will be installed. The circuit breaker protecting the branch circuit should be sized to protect the conductors from overcurrent. The NEC specifies the maximum allowable overcurrent protection for different conductor sizes. Choose a circuit breaker that is rated to trap at a current level that is below the conductor's ampacity. This will prevent the conductors from overheating and potentially causing a fire. Ensure that all wiring connections are made securely and that all grounding connections are properly bonded. Loose or corroded connections can create resistance, leading to overheating and potential electrical hazards. Use appropriate connectors and tools to make secure connections and follow all applicable wiring standards. A proper grounding system is essential for protecting against electrical shock hazards. Ensure that the dishwasher is properly grounded to the building's grounding system. This will provide a path for fault current to flow back to the source, tripping the circuit breaker and preventing a dangerous voltage from building up on the dishwasher's chassis. It's also important to consider the type of receptacle used for the dishwasher's power cord. The receptacle should be rated for the voltage and amperage of the dishwasher and should be compatible with the power cord's plug. Use a receptacle that is specifically designed for commercial appliances to ensure a safe and reliable connection. Before energizing the branch circuit, double-check all wiring connections and ensure that all safety devices are properly installed. Use a multimeter to verify that the voltage and polarity are correct. Once you are confident that everything is wired correctly, you can energize the circuit and test the dishwasher's operation. Monitor the dishwasher closely during the initial testing period to ensure that it is functioning properly. Check for any signs of overheating, unusual noises, or other malfunctions. If you notice anything abnormal, immediately de-energize the circuit and investigate the problem. It is highly recommended to use a qualified electrician to perform the electrical installation for the commercial dishwasher. A qualified electrician has the knowledge, skills, and experience to ensure that the installation is safe, compliant with all applicable codes, and reliable. They can also provide valuable advice on selecting the appropriate components and wiring methods. Working with electricity can be dangerous, so it's always best to leave it to the professionals. The use of 240 volts on a device labeled 208 volts is commonly accepted, but understanding the reasons and limitations is vital. Electrical equipment often has a voltage tolerance, typically plus or minus 10%. For a 208 volts device, a 10% increase would allow it to operate up to approximately 229 volts. While 240 volts exceeds this typical tolerance, the design of many heating elements and other components can accommodate the slightly higher voltage without significant issues. The key factor is that the increased voltage will result in a higher power output. Power, measured in watts, is proportional to the square of the voltage. Therefore, an increase in voltage leads to a more substantial increase in power. This means the heating element will produce more heat and potentially heat up faster. Whether this is acceptable depends on the specific application and the design of the dishwasher. If the dishwasher is designed with adequate thermal protection and control mechanisms, the increased power output may not be a problem. However, if the thermal protection is inadequate, the higher power output could lead to overheating and premature failure of the heating element or other components. The control circuits of the dishwasher, which operate at 120 volts, will not be affected by the voltage difference on the 208/240 volts side. These circuits are typically isolated from the high voltage components and have their own dedicated power supply. However, it is still important to ensure that the 120 volt supply is stable and within the acceptable range. Fluctuations in the 120 volt supply can affect the operation of the control circuits and potentially lead to malfunctions. When connecting a 208 volts device to a 240 volt system, it is essential to verify that all other components in the circuit are also rated for 240 volts. This includes the wiring, circuit breakers, receptacles, and any other devices that are connected to the circuit. Using components that are not rated for 240 volts can create a safety hazard. The higher voltage can cause these components to overheat and potentially fail, leading to electrical shock or fire. In some cases, it may be necessary to use a buck boost transformer to reduce the voltage from 240 volts to 208 volts. A buck boost transformer is a small transformer that is designed to either increase or decrease the voltage by a small amount. This can be a useful solution when it is not possible to directly connect a 208 volts device to a 240 volt system. The transformer should be sized appropriately to handle the load of the dishwasher. It is also important to ensure that the transformer is properly grounded and protected from overcurrent. The NEC provides detailed requirements for the installation of transformers. Before connecting a 208 volts dishwasher to a 240 volt system, it is always best to consult with a qualified electrician. An electrician can assess the specific circumstances of the installation and provide expert advice on the best way to proceed. They can also perform the necessary electrical work to ensure that the installation is safe and compliant with all applicable codes. Remember that electrical work can be dangerous, so it's always best to leave it to the professionals. In conclusion, while a 208 volts commercial dishwasher can often operate on a 240 volt system, it is important to carefully consider the potential consequences of the higher voltage. Verify that the dishwasher is designed with adequate thermal protection, that all other components in the circuit are rated for 240 volts, and that the wiring is properly sized and installed. When in doubt, consult with a qualified electrician to ensure a safe and reliable installation. Understanding voltage tolerances and potential issues is key. In the United States, nominal voltages are often referred to as 120/240 volts or 120/208 volts. However, the actual voltage available at the outlet may vary slightly due to factors such as voltage drop and transformer tap settings. Electrical equipment is designed to operate within a certain voltage range, typically plus or minus 10% of the nominal voltage. This tolerance allows for some variation in the actual voltage without affecting the performance or safety of the equipment. When connecting a 208 volts device to a 240 volt system, it is important to consider the potential impact of the higher voltage on the equipment. The higher voltage will result in a higher power output, which can lead to overheating and premature failure if the equipment is not designed to handle it. Some devices are designed with universal voltage capabilities, meaning they can operate on a wide range of voltages without any modifications. These devices typically have a built-in power supply that automatically adjusts to the input voltage. However, it is still important to verify the voltage range specified on the device before connecting it to a power source. Other devices require a manual voltage selection switch to be set to the appropriate voltage. This switch allows the user to select the voltage that matches the power source. It is important to set the switch to the correct voltage before connecting the device to power. Failure to do so can damage the device. When connecting a 208 volts device to a 240 volts system, it is also important to consider the potential impact on the wiring. The higher voltage will result in a higher current flow, which can cause the wiring to overheat if it is not properly sized. The NEC specifies the minimum wire size required for different current levels. It is important to use wiring that is large enough to handle the current flow without overheating. It is also important to ensure that the wiring is properly insulated to prevent electrical shock hazards. The NEC specifies the minimum insulation requirements for different types of wiring. The wiring should be inspected regularly to ensure that it is in good condition. Damaged or deteriorated wiring should be replaced immediately. When connecting a 208 volts device to a 240 volt system, it is also important to consider the potential impact on the circuit breaker. A higher voltage will result in a higher current flow, which can cause the circuit breaker to trip if it is not properly sized. The NEC specifies the maximum circuit breaker size for different wire sizes. It is important to use a circuit breaker that is sized appropriately to protect the wiring from overcurrent. The circuit breaker should be tested regularly to ensure that it is functioning properly. A faulty circuit breaker may not trip when it is supposed to, which can lead to overheating and potential fire hazard. When connecting a 208 volts device to a 240 volt system, it is also important to consider the potential impact on the grounding system. A proper grounding system is essential for protecting against electrical shock hazards. The grounding system should be inspected regularly to ensure that it is in good condition. Damaged or deteriorated grounding connections should be repaired or replaced immediately. When connecting a 208 volts device to a 240 volt system, it is also important to consider the potential impact on other devices connected to the same circuit. The higher voltage can affect the performance of other devices, especially those that are sensitive to voltage fluctuations. It is important to ensure that all devices connected to the circuit are compatible with a higher voltage. When in doubt, consult with a qualified electrician to ensure that the installation is safe and compliant with all applicable codes. Here are some additional factors to consider. Firstly, check the dishwasher's documentation. The manufacturer's instructions are the best source of information on voltage compatibility and wiring requirements. Secondly, consider the load characteristics. The dishwasher's power requirements will determine the appropriate wire size and circuit breaker rating. Thirdly, examine local codes and regulations. Electrical codes vary by jurisdiction, so it's important to comply with all applicable requirements. Fourthly, think about future needs. If you plan to add more electrical equipment in the future, consider installing a larger electrical panel to accommodate the increased load. And fifthly, perform regular maintenance. Inspect the wiring, circuit breakers, and grounding system regularly to ensure that they are in good condition. In summary, connecting a 208 volts commercial dishwasher to a 240 volt system can be done, but it requires careful consideration of several factors. Understanding the voltage tolerances of the equipment, the wiring requirements, and the potential impact on other devices is essential for ensuring a safe and reliable installation. When in doubt, always consult with a qualified electrician.